Hello there, my name is Ajiboye Isaac, and today we want to continue our lesson on approximation and a special area of concentration is percentage error. Percentage error. So, our learning objectives at the end of the lesson, students should be able to mention and briefly describe types of approximation error, determine error limits and allowances of measurements. Approximate numbers to nearest decimal places, significant figure, figures significant figures and place values. And then finally, determine error of approximation and percentage error. Key vocabulary words. Figures. Figures are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Digits. Digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You will notice the difference between figures and digits. In figures, you do not have 0. In digits, we have 0. Place value system. The value of a figure or digit in a decimal number system. For example, in 543.287, 3 is unit, 4 is 10, 5 is 100, 2 is tenth value, 8 is hundredth value, and 7 is thousandth value. You will note that place value after the decimal point ends with th. Absolute. Absolute of a value is the unsigned of that value. It is denoted by /x. Okay, thus absolute of minus x is x, and absolute of x is also x. So you see that we only pick the x in the absolute. All right, so for example, the absolute of minus 3.5 is 3.5, and the absolute of 3.5 is also 3.5. So you watch out for that word absolute in our lesson, in our examples. Errors. Approximation or estimate of values could result in a slight deviation from the original value. This deviation is referred to as error. That is a deviation from the original value when you approximate is what we refer to as error. Therefore, error is equal to the absolute of estimated minus real value. Therefore, error is equal to estimated minus real value, the original value, the absolute. For greater accuracy, the error must be reduced to the barest minimum. The error must be reduced to the barest minimum. It is very, very important that while you do your approximation, the error should be reduced to the barest minimum. Shouldn't be that significant, right? And it is such that it should not deviate from the original value. Okay, there are two possible errors. One, approximation error, and two, measurement error. It is very important that we differentiate between these two. Approximation error and measurement error. There are two different errors, all right? Measurement error. This is the error made as a result of the difference between the actual quantity and measured value of the quantity. So when you are trying to, the measurement error is error observed when you are trying to measure, when you are trying to take a measurement. So you make a mistake, or you measure below or above the actual value, right? This could be as a result of parallax error and other sources of error. All right, so that's just measurement error. Okay, so this is the error made as a result of the difference between the actual and measured value of a quantity. Approximation error, on the other hand, this is the error due to the degree or unit of approximation. So when you approximate, and when you approximate, you either round up or round down. So that error, as a result of you rounding up or rounding down, is approximation error. And of course, it shouldn't be significant as well. It should be to the barest minimum. Okay, it shouldn't bring about a value that will be too different from the original value. Okay, so example, error with number corrected to one significant figure is not the same as when corrected to two significant figure or three decimal places. The maximum error is found by taking half of the digits obtained from the degree of approximation. I'll take that again. The maximum approximation error is found by taking half of the digits obtained from the given degree of approximation. So let's say, for instance, you want to approximate to two decimal places degree of approximation. Because it is two decimal places you want to approximate to, then you take half of the last digit, or let's take half of the second decimal number. All right, that will be 0.01. Okay, we'll see that in the examples that we'll consider. But just that you must bear in mind that the degree of approximation is where you are going to consider, and then you take half of that degree. That is the approximation error. And in some cases, we consider this approximation error as allowances or limits of measurement. So if you look at most physical measurements that you would come across, we always usually have allowances, okay, for error, plus or minus. So that allowance comes with plus or minus. So you bear that in mind. Approximation error is usually referred to as allowance, and is usually represented as plus or minus error, which is equal to plus or minus half the degree. Okay, plus or minus error, which is equal to plus or minus half the degree. All right, and like I said, it is refers to limit or allowance in certain physical measurement. So let's look at percentage error. This is the ratio of the error made to the original value. This is the ratio of the error made to the original value. Thus percentage error is equal to error over original value times 100. Percentage error is equal to error over original value times 100. Let's look at some solved examples. A firm employs 130 men, and the average weekly wage per man is 34 naira, correct to the nearest naira. The average weekly wage per man is 34 naira, correct to the nearest naira. What are the greatest and the least possible weekly wage bills for the firm? What are the greatest and the least possible weekly wage bills for the firm? Solution. Weekly wage of one man is 34 naira to the nearest naira. Okay? That nearest naira means to the nearest 1 naira. So it's possible that the wage of a man is 34 naira 00 kobo, or it is possible it is 33 naira 00 kobo. That is, it is possible it is 33 naira, it is 34 naira 3 kobo. it is possible it is 34 naira 30 kobo, but to the nearest naira now. And it is possible that it is 33 naira 50 kobo. Because if you approximate 33 naira 50 kobo to the nearest naira, you will still get 34 naira. And if you approximate 34 naira 40 kobo to the nearest naira, it will still give you 34 naira. So we look at these limits, and that is what we refer to as allowance or approximation error. So this case is a case of approximation error. Therefore, our plus or minus error will now be equals to plus or minus half of the naira, right? Which is 0.5 naira. That is plus or minus 0.5 naira, which is 50 kobo, by the way. Plus or minus 50 kobo. What does that suggest? It simply means that the approximation of the weekly wage of one man could be from 33 naira 89 kobo, 33 naira 80 kobo to the nearest naira 33 naira 90 kobo, 95 kobo, right? And again, it could be as a result of 34 naira 40 kobo. That is, it will not, the approximation will still be the same. Okay, so if you take half of the nearest naira, that will give you 50 kobo. So therefore, the weekly wage per man is between 33 naira 50 kobo and 34 naira 40 kobo. I'll say that again. The weekly wage per man is therefore 34 plus or minus 0.5 naira, which is the same thing as 34 plus or minus 50 kobo. And if you look at that range, the range is therefore 33. That is, if you subtract 50 kobo from 34 naira, you get 33 naira 50 kobo. And if you add 50 kobo to 34 naira, you get 34 naira 50 kobo. Are you there now? So weekly wage per man is in that range. So the weekly wage for the firm for 130 men would therefore be equals to 130 times the range. And in this case, you have 130 times 33 naira 50 kobo to 130 naira to 34.5 kobo. So the weekly wage for the firm will therefore become 435 naira 50 kobo and 4,355 naira to 4,485 naira. That will be the weekly wage, just by multiplying by the number of men. Okay, so what we did there was to first of all get the limits of the weekly wage per man, and then multiply by 130 by the number of men. That's all. Example 2. The answer to a mathematics question in an international exam is 23.4 to 3 significant figure. Determine the allowance for correct answer. Okay, you can see that it is to 3 significant figure, and this 3 significant figure is, you will notice that it is the 10th. That 3 significant figure is the 10th place value, is the 10th degree. Okay, so the 10th degree is 0.1, as you know. So the allowance, or the plus or minus error, will now be equals to plus or minus half of the 0.1. So that will therefore be equals to plus or minus 0.05. Allowance for correct answer will now be equals to 23 point plus or minus 0.05. And so the allowance is now 23.35 to 23.45. If the correct answer is 23.4, right? If a student should give an answer of 23.35, then the student will be considered correct because it's within the limit. If the student should give 23.48 for instance, 38 for instance, the student will be considered correct because if you approximate 23.38, then you still get 24. You still get 23.4 rather. I'll say that again. Our allowance is 23.4 plus or minus 0.05. That is 23.45, and the range of 23.35 to 23.45. That's the range because of the plus or minus 0.05. If you add 0.05 and subtract 0.05, you get 23.35 and 23.45. So if a student should score within that range, the student will be considered or given a full mark because the answer will be considered to be correct because it's within the range of the limit. Example again. The diameter of metal rod is measured as 23.40 centimeter to 4 significant figure. What is the maximum error in the measurement? What is the maximum error in the measurement? Okay, if you look at that question now, you see that we have to the nearest hundredth. You can consider that to the nearest hundred. The degree there is hundredth. Okay, so if you now take the plus or minus error of the hundredth of the 100 degree, that will now be equal to plus or minus half times 0.01, which therefore be equals to plus or minus 0.005. Thus, the measurement is 23.40 plus or minus 0.005, while the error or allowance is plus or minus 0.005. Okay, so we cannot allow anything that will go beyond that range, right? Anything that go beyond that range will therefore amount to a significant error. Okay, this error will become significant. So that's the meaning. So another example, the radius of a circle is 2 centimeter. A student measured it as 2.01 centimeter. Find the percentage error in the area of the circle. Okay, you have been given the radius. The actual radius is 2 centimeter, but the student measured it as 2.01 centimeter. They want us to find the percentage error in the area, not in the radius, but in the area. So what it means is that you will calculate the area using the actual radius, and you will calculate the area using the estimated radius. So if you calculate the radius using the actual radius, you get 4 pi centimeter square. And if you calculate the area using the estimated radius, you get 4.0401. All right, so the percentage error will now be equals to 4.0401 pi minus 4 pi over 4 pi. Okay, and if you simplify, that will give us 1.0025%. So you can see, mind you, for any type of error, you can be asked to find the percentage error. Either is a measurement error or is approximation error. You can still be asked to find the percentage error. All right, and the percentage error determines how accurate a measurement is. If the error percentage is small, then the degree of accuracy of such a value or measurement will be very high. Okay, but if the percentage is high, then that answer will be tending to a wrong or incorrect value. So let's bear that in mind. So this is a classwork just to test your understanding. Try it and forward your attempt to my WhatsApp number so that I can guide and correct. Please make attempt. Try and listen to all the explanation of the example again and again. Follow the steps and then apply. I am sure this class will be a piece of cake for you. Then assignment is due first thing tomorrow morning. Attend the assignment. use the steps in the example and forward the attempt to my WhatsApp number. I'll be willing to guide you. I'll be willing to assist you. I want to commend the effort of those that did the previous assignments and classwork. You're on the right path to success. Keep it up. And I pray that God will crown your effort. For more videos, you can visit Matzik YouTube. On the YouTube is my YouTube channel. For more videos, you can visit Matzik and help yourself with other topics as you may have interest. Thank you for listening.